Okay.
So, Steve, can you pass me some dirt by reference, please?
Here you go.
Okay, so now if either of us change the dirt block, it's changed, right?
Yes.
Steve, can I have some dirt by value?
Here you go.
Okay, so now I can change mine and you can change yours. Good, cool, excellent. Close enough. I'll get it in post. All right, so now that you've got a little handle on pass by value and pass by reference, I'm going to really twist your head off. And this is subtle, okay? This is not easy. This is real subtle. And it's a little bit confusing in a bunch of ways. So you have to watch this through a couple of times. You have to ask me questions. Like, totally understood. I mean, I would understand that. This is real weird. Takes more than a second to figure out. So the deal here is that Python actually only does pass by reference. So it only points at the same object. Now, it also fakes that. So it cheats a little bit in the background, and that's where this distinction between mutable and immutable types comes in. You're gonna, sharpen your brain for this one, okay? Real slow. I'm gonna say this, and it's gonna seem like I'm insane, okay? There's a little bit of sourcing in the repel here. Feel free to look it up. First things first, every variable is some kind of object. That's why when you do something like, so here I declared a couple variables. If I ask for print out the type of X and hit run here, I'm going to get class int, right? That says it's an object, it's a member of the integer class. That thing's got some methods, it's got some stuff, that's how it works. What that means in like most languages, objects are all passed by reference. They're passing them by value is quite a bit harder. So Python does that. Everything's passed by reference. Now the subtlety here is that some things are what are called immutable variable types. And immutable means that they can't be changed after they're created. And examples of the immutable types are like the built-in binary typed variables. So integers, floats, Boolean strings, Unicodes, binaries, tuples, basically things that are going to take up a set amount of space are all immutably typed. And that's because when they're created in the memory in the computer, right, there's all these little on-off switches in the memory. And that means that we can just say, look, because we know how big you are, you're going to get switches, a bajillion through a bajillion plus 100, right? Like, those are your switches. And with a mutable type that can change size, that memory allocation process is a lot more complicated and takes a lot more time and space. So the immutable types are a space-saving measure. Now, the weird thing is, I'm sure you're thinking, but dude, I declare X as X is 10, and then like 20 lines later, I declare X is 11, and it doesn't have any problem with that. And that's true. But those aren't the same X. So what it's doing is the computer has, the compiler, right, has what it means by X, and what it means by X points at a spot in its list of memory locations. And then when you reassign X, it changes which spot it's pointing at. So it literally just forgets the old X and puts a new X somewhere else. So it just changes where it's looking for X. When you change a mutable variable type, it actually leaves the place in the memory the same. Now, there's some subtleties here because things are complicated. Because I don't know, for some reason this has to be hard. Probably because it's hard. That's okay. So let me look at these. So I made a variable x, I set it equal to 10. I made a variable y, I set it equal to x. So those really should be the same thing now. And then I'm printing out the type of x, which is this class int thing. So I guess I don't need that one anymore. Oops. I don't need that one anymore. I'm going to comment these 2 lines back in. So those are, this ID tag is just something I'm using for this lecture. I don't give a hoot if you use this anywhere else. You probably never will. The only thing it's good for is checking whether 2 objects are exactly the same place in the memory, not whether they contain the same value. So if I hit run, I get these 2 memory locations, right? That's what these IDs are. Okay, I'm lying a little bit. They're not actually memory locations. They're a key to some kind of a dictionary or a hash table or something that contains an actual memory location. But whatever. They may as well be where you go look, right? So see how the exact same number? That means they're pointed at the same spot in the memory. Now, if I change one of them, like I change y by adding 1 to it, and then print out the ID of where y is, see now it's different? So what happened there is the old y was located at the same spot in the memory that x was, but then when I changed y, what it did was it discarded the old one and made a new one. Right? So x is still at the same spot, y is now different. That even works if I'm using this other kind of operation. Right? And see, every time I run this, oops, canceled. Every time I run this, I'm going to get different IDs because they're going in a different spot in the memory every time I run this. They go in the same spot there. Okay. So even with this one, with an immutable type, it goes to a new spot in the memory. Now, this is where things get a little wacky. So let me make a player list. So here's a list with a couple of names in it. Let me print out the ID of that thing. Okay, so that's going to be where it is in the memory. And then if I do player list is player list plus, let me put in some random name. Oops, I run this, I get nothing. Let me comment out the other stuff. And let me reprint out the player list ID. Okay, so see how those are in different spots? That's working the same way it was before, right? Now check this out. Uh-oh, I crashed my repel. Try that again. I promise that wasn't my fault. That was just a random repel crash. See how they're in the same spot in the memory now? So this is a little bit wild, but the operations assign this thing to itself plus something, and this kind of augmented add operator are actually a little bit different. So one of them's doing a passing by reference and then a reassign, and the other one's just doing an overwrite. So let me pass along the best piece of oh yeah, and there's also append. Append would be another way to do this. Append acts like this one. So maybe let me pass along the best advice I got for this thing, which was, or the best phrasing I found. Immutable variable types are are only assigned once to a memory location. And when you reassign the variable, the memory location changes. Mutable variable types, on the other hand, can be changed in situ. So you can change them in the place that they're in the memory. Now, that means that you have to be a little bit careful about how you alter things, because when you're using a function to do stuff, like down here I have this, okay, so at this point I have a player list, right? So when I run this, I'm going to see ztux, finance wave 7, and rando are going to print out here. And then I'm just defining a function, and then I'm running that function, and that function appends pretty face Robert 100 and regular old adds pretty Robert, and then prints out that list, and then prints out the old one. Now, because this is passed by reference, right? It's pointing, because I'm calling the add Robert function on the player list, and so it's going to point at the place in memory that player list lives. So it's pointing at this spot that has these 3 names in it. And then it's doing append, which is one of the mutable methods, right? So it's gonna put at that location in memory. It's gonna add pretty Robert 100, and then it's doing the other kind of addition with this add. So pretty Robert's gonna get added to the list, but that's gonna go into a new spot in the memory because that's the new memory assigned one. And then when it goes through the prints, right? So this first one is going to print out 3 players, right? That's going to be ztux, finance wave, and rando. Then we're appending pretty Robert 100, and that goes in the same spot in the memory as the first 3 players did. Then we're going to add pretty Robert, and that's going to go in a new spot in the memory. So there's going to be a list now with 5 people in it, but it's in a new spot in the memory. We're going to print out the thing that's in the new spot in the memory. And then after that executes, we're going to print out what's in the player list spot in the memory, which is the old spot in the memory, which is going to contain ztux, finance wave 7, rando, and only pretty Robert 100. Guys want to see that? So pretty Robert disappeared because pretty Robert was at this spot in the memory, right? This PL spot in the memory. Well, it's not really PL, but it's the kind of new spot in the memory that was created by this assignment operator. Now, the really jacked thing is if I switch this order, now this one's making a new spot in the memory, and then this append is happening to that new spot in the memory. So it's not going to remember either of these after the method runs. Okay, see that? This is super jacked. It's really, really subtle, but there's 3 operations, right? The 3 operations that we can use to add something to this list are the plus equals operation, the list equals list plus new thing kind of style, right? And so this one would be the list plus equals new thing. And then we also could use the built-in append method. And let me maybe put the ones together that work the same. So this first one creates a new memory location. A new storage location. These other 2 add to the memory location that exists. Now, none of this matters for immutable types. Immutable types always create a new memory location. So if you change an immutable type in a function, it's gone, man. Like, in order to get it back, you need to return it. It's always going to create a new spot in the memory. It's never going to do this weird thing where it can actually alter. Now, this does get a little funky when you talk about tuples. So this says a tuple's an immutable type, which is true, but that doesn't mean it can't contain mutable elements. So you can make a tuple out of a couple of integers and a list, and then the list is mutable still, but the integers aren't. I hope that makes some small amount of sense. So I'm not going to comment this strictly because this is really just me kind of playing around. I am going to tack on to the front of this video a little something talking about passing by value and passing by reference. But remember, those aren't a thing in Python. Python only passes by reference. Everything's an object here. That's how all of it works. It's just that there's this distinction between mutable objects where you can have the same thing in memory get changed, and immutable objects where changing it just is a full new location, forget the old thing, we'll just put it somewhere else. And then it's worth noting that there are operations that work immutably for mutable things. This has probably been hella confusing. Let me know when you run into these issues. They will happen. And good luck. You may need it.